Digital Literacy Introduction to Networking Part 1 Exercise 1 Networking Fundamentals. Exercise 1 Networking Fundamentals. A network includes two or more computers that are linked together for the purpose of sharing resources, hardware, and software and exchange data. Every computer network has at least one switch where we can connect end devices, computers, printers, IP, phones, and other devices. And at least one router that represents the main device in a network and connects us to the outside world. Today, most enterprise networks follow a typical network scheme where they have one central site and headquarters and a couple of remote sites, branches for them to communicate. We need a router at each site. Routers usually have two interfaces, one connected to LAN switch and other for to a one link. The network connects to the internet and other remote sites or headquarters over this one link. A switch is a networking device that connects end devices. In a network, it is multi-port network bridge that forwards database on an Ethernet address, MAC address, which is stored in the MAC address table. MAC addresses are 48-bit long binary number, but most devices show MAC addresses as a 12-digit hexadecimal number. Cables are the transport medium through which data actually travels in a network today. The two most commonly used cable types are copper and fiber optics. In this exercise, you will learn about different types of networks and the advantages of network computing. Learning outcomes. After completing the exercise, you will be able to type of network advantages of network computing. Your devices. This exercise contains supporting materials about network computing. Types of networks. There are several types of computer networks that are available. Following are some of the most common type of networks. Local area network, which is LAN, a network in which two or more computers are connected together within a small geographic area such as schools, offices, or buildings that are located close to each other. Wide area networks, which is WAN. A WAN network interconnects multiple local area network LANs distributed over a geographically spread area. An example of wide area network is Internet Metropolitan Area Network, which is MAN. A MAN network interconnects computers for the purpose of sharing resources within a town or city. Virtual Private Network, which is VPN. VPNs encrypt traffic between a private network such as an office internal network and public networks such as internet. They are used to ensure secure transfer of information. Advantages of networks computing. Sharing resources such as hardware and software. Data is stored on a centralized file server. Hence, it is easier to backup data and share files with users within an organization. This also helps in reducing costs and increase storage capacity. Allow electronic communication between users. File can be retrieved from any computers on the network. Let's proceed to the next page. Okay, and then exercise 2. Know about the OSI model. In order to fully understand layered model and to be able to apply this to the lab activities that will take place in subsequent exercises. This exercise will give you a brief overview of layered networking models. In this exercise, you will review the structure and function of the OSI model, and you will compare it to another layered model. The TCP/IP model, you will also see how the OSI model structure can be used and aid in troubleshooting. Please refer to your course material or use your favorite search engine to research this topic in more detail. Learning outcomes. After completing this exercise, you will be able to explain the history of structure of the OSI model. Compare the OSI model to the TCP/IP model. Use the OSI model to implement troubleshooting. Your devices. This exercise contains supporting materials about the OSI model. Explain the history and structure of the OSI model. The Open System Interconnection OSI model was originally published in 1984 by the International Organization of Standardization, or ISO, and the International Telecommunication Union, ITU-T. It was used to standardize network protocols, allowing the interoperability of vendor equipment. The OSI model defines 7 layers. Layer 7 application, Layer 6 presentation, Layer 5 session, Layer 4 transport, Layer 3 network, Layer 2 data link, Layer 1 physical. Figure 2.1 diagram OSI model 7 layers of the OSI listed in the hierarchical order. Several protocols have been developed based on this model, including X.25, Token Bus, ISIS, and CLNP. Today, the OSI model is used primarily for teaching purposes, as it has been largely surpassed by the TCP/IP model. Compare the OSI model on the TCP/IP model. Although the OSI model was developed to be used openly by all vendors, another model was practically adopted by the telecommunications industry. This is the TCP/IP model. The original TCP/IP model was composed of 4 layers: TCP/IP model, original application, transport, internet link. Okay, Figure 2.2 diagram of the TCP/IP model. 4 layers of the original TCP/IP model listed. Even though the vast majority of networks today are based on the TCP/IP model, the layers of the OSI model are most often referenced rather than those of the TCP/IP model. For example, when using the term layer 2, it is referring to the data link layer of the OSI model. It is where technologies such as MAC addresses and internet functions, even though this function is layer 1 of the TCP/IP model. Similarly, layer 3 refers to IP addressing and routing, which is the network layer of the OSI model. Even though this function occurs in the internet layer of layer 2 of TCP/IP model, when referring to a layer, it is only the OSI model that is referenced. Okay, the TCP/IP model maps to the OSI model according to the following diagram. Okay, TCP/IP model, OSI model, application, layer 7 application, layer 6 presentation, layer 5 session, transport, layer 4 transport, internet, layer 3 network, layer 2 data link, then link, layer 1 physical. Figure 2.3 diagram of TCP/IP and OSI models. Original 4-layer TCP/IP model mapped to the OSI model. Although this original model still remains the official layered model, some experts and professionals have accepted an updated version of the TCP/IP model with 5 layers that map more appropriately on the OSI model. This updated TCP model, along with the mapping of the OSI model, can be seen below. Okay, on figure 2.4 diagram, the TCP/IP and OSI model updated 5 layers TCP/IP model mapped to the OSI model. Note that this updated TCP/IP is referenced here only for completeness and has not officially replaced the original TCP/IP layered model. For the remainder of the lab, when referring to the specific layer, it is the layers of OSI models that will be relevant and not those of the TCP/IP models mentioned above unless explicitly stated. Okay. Okay. Use the OSI model to implement troubleshooting. The OSI model can be used to implement several different types of troubleshooting. This includes the top to bottom and bottom to top approaches, as well as the divide and computer method. All of these reference the OSI model and indicate at what layer the troubleshooting will begin. The top-bottom approach, as its name suggests, involves beginning at the top layer of the OSI model, that is beginning with the application layer and working your way down. Okay, OSI model, layer 7 application, layer 6 presentation, layer 5 session, layer 4 transport, layer 3 network, layer 2 data link, layer 1 physical. Okay, figure 2.1 diagram, the OSI model order, follow the implementation of the top-bottom typically connectivity, troubleshooting using the layers of OSI model. An example of this would be the example network connectivity by opening a web browser and attempting to connect to a web page. If this doesn't work, move down several layers and test that the appropriate ports in the transport layer are open. Next, check IP connectivity with a ping. Continue down until reach the layer where the problem exists and solve it. The bottom of the top approach is much the same, but begins with the bottom of the OSI model and works its way up. Okay. OSI model layer 7 application, layer 6 presentation, layer 5 session, layer 4 transport, layer 3 network, layer 2 data link, layer 1 physical. Figure 2.6 diagram of OSI model order follow the implement of the bottom to top type of connectivity troubleshooting using the layers of OSI model. For example, on a PC without a network connectivity, the first thing you can check is physical cable connectivity and that the LEDs on the switch and the NIC are on. Next. You can check that the NIC is functioning and that the switch ports are configured correctly and in working order. The next, check IP connectivity using the ping command. Keep going up a layer until the problem is located and solved. The divide and conquer approach begins at one of the middle layers and works either up or down from there. OSI model, layer 7 application, layer 6 presentation, layer 5 session, layer 4 transport, layer 3 network, layer 2 data link, layer 1 physical. Okay, figure 2.7 diagram of the OSI model ordered now followed to implement the divide and conquer type of connectivity troubleshooting using the layers of OSI model. You can begin, for example, with a ping starting at a layer 3. If it doesn't respond, move down a layer. If it does respond, move up a layer until a program is found and solved. Continue to the next exercise to begin applying your knowledge of the OSI model to the network. Okay, let's proceed. Okay, on exercise 3, layers 1, 2, 3 of the OSI model. In this exercise, you will examine various portions of network and you will identify them as part of specific layers within the OSI model. This exercise deals with the first three layers of the OSI model, namely the physical data link and the network layers. To better understand this technology, also refer to course material or use your preferred search engine to research this topic in detail. Okay, learning outcomes. After completing this exercise, you will be able to examine the components of the physical layer of the OSI model. Examine components of the data link layer of the OSI model. Examine components of the network layer of the OSI model. Your devices. You will be using the following devices in this lab. Please power on this now.